let's dive in. Welcome to this session on paving a painless path to production AI in your Java applications. My name is Mark Heckler. I'm Principal Cloud Advocate of Java and JVM languages at Microsoft. If you have any questions, I'm going to try really hard to save a few minutes at the end for Q&A. But if not, or if you think of something 10 minutes after the fact, which is usually what I do, by all means, reach out to me via email or via X. Wow, that's hard to say. Anyway, so let me advance this. There we go. Okay, a bit about me, very little bit about me. I am primarily a developer, an author, and a pilot. So an advocate. So everything else is super nice to add in, but basically it comes down to that. So with that, you didn't come to hear about me. You came to hear about this. I think it's useful to establish what this session is not before we dive into what this session is, so we kind of are on the same page. It's not meant to be exhaustive because, after all, we only have 30 minutes. Yikes. But we will be talking about various different things. We just can't go very deeply into it. It's basically a conversation starter. We have 30 minutes today, and we have potentially unlimited time after that. So let's make the best of it to kind of prime the conversation and then continue it after the fact. What this session is really intended to be is a fast-paced, selective introduction of key AI concepts, as well as a quick review of the tools at your disposal for building AI-enabled applications. So kind of here are the things you can build with, and here are the concepts, here are the things you can build with, and then let's get in and get our hands dirty with a live coding adventure to demonstrate those concepts using Spring Boot Java and Azure OpenAI. I do, at the bottom, point out that the concepts are portable, so if you're not using those tools, well, the first question would be why? But the second point I would make is that all the concepts really apply across the domain. It's just that I try to use best of breed. So that's, those are the big three in my mind. Anyway, so again, to kind of summarize the plan, we'll talk concepts. We'll see how those concepts translate into reality. We'll see it in action because that's really where it in my mind, catches traction. And then we'll continue the conversation after the fact. So very, very briefly, again, this isn't meant to be exhaustive, and I do tend to generalize when my time is very, very short. So this will be a fairly quick, high-level overview. If you want to discuss this more, again, please ping me later. So when you talk about AI, you typically talk about large language models. So inevitably, you hear things thrown around about models. Makes sense. Typically, we kind of break things or categorize things into models generate something. So models generate text, images, or audio. There is actually a generative AI for video now, but it's not really widely available. So Sora exists. It's beautiful, but it's not really something I'm going to be covering today because it's not widely available. Whereas these others are. They're pretty well established in AI time now. So they, as you might imagine or might note, I've mentioned generative. These are generative AI, and by that, it means that it generates an output of some kind. In fact, GPT stands for Generative Pre-trained Transformer, which means that the large language model is pre-trained. You don't have to provide a bunch of training to it to make it useful out of the gate. It transforms inputs, prompts, if you will, into responses, and it generates those responses and then provides those. And GPT, that's where we get the name Chat GPT. You'll often hear tokens and tokenization spoken of. And tokens are the most atomic level of granular of context for an AI. So in language, in natural human language, we think of words as being the most granular, the atomic level of context. And tokens roughly equate to a natural language word. It's not an exact match. Generally speaking, tokens are about 3/4 of a word, so it's a slightly greater atomicity, if you will. So if you have like a 1,000-word document, it's roughly equates to about 1,330 some tokens. But that's how an AI understands, and I say, you'll hear me anthropomorphizing a lot throughout this, but that's how an AI will make sense. You establish some context, relevant context for any particular topic. Embeddings you hear spoken of often, typically in the context of an embedded data, or excuse me, embeddings in a database. But embeddings are, again, kind of overgeneralizing here, but they're a way to draw similarities and dissimilarities and assess those. so that you get better results from prompts going in and better results coming back out. So an embedding, let's say you had an animal, a body of knowledge about animals. So if you have a database about various animals, you want to do a prompt, a query about a particular kind of animal to see what other animals are similar. So for instance, a house cat has 4 legs and other various attributes that are cataloged and weights assigned and calculated and then stored. So a house cat might be assessed for similarities with something else, and we might come back with a domesticated canine, a dog. And of course, they both have 4 legs and whatnot, and they're able to be housebroken and things of that nature. So a cat would have more in common, more similarities to perhaps a wild rhinoceros. So embeddings help the LLM to make sense of what, or the AI to make sense of what is more common and less common, more dissimilar. Retrieval augmented generation, very fancy term. We usually shorten it to RAG because we in tech love our TLAs, our 3-letter acronyms. But it kind of explains itself, even though it sounds very fancy. It's an augmented way to generate and retrieve results. So you augment it typically with your own data. Now, there are a couple different ways to do that primarily, but largely what I will talk about and show you here later on is stuffing the prompt, which means you provide additional context for your query so that it operates on basically on your data or more specific data. So for instance, if you're working for an insurance company, you want to get some kind of draw some conclusions based on your policyholders, that would be much more specific, and you would augment your search rather than have it operate on the entire populace as a whole. So it allows you to get more specific and get more meaningful results potentially. And again, all of this is evolving because literally you can, like I do, sign up for nightly updates, nightly build, nightly releases. So literally from day to day, this can change. And if that's a little too fast for your taste, you can dial that back. But literally this stuff is moving very quickly, and you can just stay as fast on that leading edge as you want. It makes for some exciting times. So very quickly, those concepts translate to reality via a couple different mechanisms. One is applications, and 2 is APIs. And from a developer perspective, we're far more concerned with APIs, but it's not like we don't notice the other stuff, right? So in terms of applications, ChatGPT, Microsoft Copilot, and let's say GitHub Copilot work. They take text, they retrieve, they generate text. DALL-E generates images. You have various different API-based models for audio. As far as I know, there's no widely available audio application, consumer-grade app. Probably is out there somewhere, but it's not widely available. But all of these things typically are available via APIs. Occasionally, we'll have an edge case, a model that isn't available via API, but most of the time, we developers have access. And that's really what we're after, because most use cases involve some kind of API access. And currently, most use cases are textual. Doesn't mean they'll stay that way, doesn't mean they're all that way now. And certainly they will, those various different valuable use cases will evolve and expand. But right now, kind of the low-hanging fruit, not super fan of that term, but it's there for a reason. The low-hanging fruit is there for textual use cases because there are so many that we can apply AI to usefully and fairly quickly in the grand scheme of things. Useful abstractions do add significant value, though, because all of these models may have varying APIs. And as developers, we want to make the maximum use of our time. And in areas of commonality, to have useful abstractions makes us much more productive and generally happier. It makes our code more maintainable as well. So in terms of tools, let me start with VS Code. VS Code, Visual Studio Code, is a great cross-platform, multiple language supporting IDE available for a download. It has great Java and Spring Boot plugins, great AI plugins, as you might imagine. GitHub being a company, Microsoft company, and they produce great software, GitHub Copilot, which is available first on VS Code. If you want to check it out, go check it out at code.visualstudio.com. And within a couple of minutes, after the talk, by the way, and within a couple of minutes, you can be up and running with that. And of course, GitHub Copilot. That's also available for IntelliJ IDEA. Now, a lot of Java developers use IntelliJ. I use IntelliJ. I also use VS Code. Some folks use one or the other. Some folks are like me. We use them both and love them both. So whatever your tool of choice, you actually can use GitHub Copilot to great effect. And I like to break Copilot into 3 different modes. Kind of maybe, again, once overly simplifying, but it's kind of useful to categorize. So read my comments is the first one. I don't use it as much, but it's useful when I want to, which is you write a comment, let's say in a class file, and based on how well you define what you're after, Copilot will create a method for you, for instance. And I do want to say something about that, because just as in conversation, the more specific you are, the better the understanding. So if I start a sentence by saying, I woke up hungry this morning, I have no food in the house, I really need to go to then obviously most of us would complete that sentence in our heads with the store, the supermarket, the corner market, or whatever. But even there's some variability, right? So if you provide a very non-specific comment, Copilot won't have as much to work on, and chances are you've probably heard the term hallucination. Chances are there'll be more of a chance of hallucination just because there are fewer tokens there to process to anticipate what should come next. But if I fill out more, the fidelity goes up very, very quickly. So it's incumbent upon us to maximize communication, just as it always has been. Better inputs equal better outputs. You can also use what I call read my mind or code with me. And that's kind of the mode that I fall into most of the time, which is I start writing code. I'm kind of in the flow. And Copilot, again, if I start off with a method signature, it may get enough context from that to go ahead and provide a method in part or in full that will meet my needs or approximate it. And you'll see sometimes that does brilliantly, sometimes it does okay. And again, part of that is just how much specificity I provide going in. Copilot Chat, which allows you to open up a chat window. And you saw this in the keynote in one of the earlier demos prior to mine, which is that you can write up something like, create a use case for this particular class and test these 3 things. And by doing that, it's more conversational. Copilot will provide you a test case. You can drop that into a new file, paste it into your current file, and so on and so forth. So check it out, github.com/features/copilot for more. And then, of course, you'll need a place to deploy these apps. Azure has numerous different targets for deployment. And these are the 2 that I lean into the hardest. So of course, I'm going to talk about them. In fact, I know there'll be just no time to share them with 30 minutes. But of course, if you're developing Spring Boot applications, Azure Spring Apps is a great home for those. Azure Container Apps also is a great home, but it also just kind of accommodates any kind of containerized app. So if you're building containers with any language, check them out, and others. So let's code. I'm going to just switch over here to the Spring Initializer. Let's see, how much time do we have? Doing great. Okay, so 10, 12, 13 minutes, we're good. So I'm going to just take this from concept to creation. And that's how I think best. I see it in action. So I'm going to use Maven for the basic, the build system for the project, using Java for the language, 3.2.4, the current version of Spring Boot. I'm just going to change some of the coordinates here. So the hecklers.com for the group. We'll make this our JD AI demo. And I'm going to use the current LTS version of Java. You can go up to the newer one that just released 22, or the previous LTS for 17. But I'm going to go right down the middle here. We'll keep it nice and simple. I'm going to bring in Azure OpenAI and Spring Web to build a web API. And then we'll generate that. And we'll drop that out here on the desktop. And then I will go out and open that up. So we'll open that. And of course, it dropped it over on one of my other monitors. So I'll just work with where it is. It's fine. I just need to open the project. Well, I'll bring it over. Open the project. You know what? I'm actually just going to open this up right here. Look at that. So I'm going to open the project in VS Code. Again, whatever you want to use, that's perfectly fine. And that, for some reason, let me bring that over. Bump that up. We'll close that window out. And we will open the POM. And of course, it's indexing. Let's try that again. POM. It is just going to make me do this all by hand today. That's perfectly fine. Let me bump that up to make it a little more readable. We'll do that later. And of course, you see that we added in a couple of things. We have Java version 21, Spring AI version, which is the current in-progress version of 0.8.1. And of course, we have Spring Boot Starter Web and the Azure OpenAI Spring Boot Starter, and is exactly as we expected to have. I will show the application properties. You're going to need to configure your application to have an endpoint for your model, the model type, the name, I should say, deployment name, things like that. You can put those in your application properties. It's not a good practice because in your embedding secrets in your app, I actually load those in the command line so I can pull those in. Spring Boot applications absorb command line properties, or excuse me, environment properties, as well as command line properties. But of course, in a production environment, you'd probably put them in something like Key Vault to hide those secrets. For now, it's fine. They're hidden, at least from view. The next thing I want to do is pull up the application. And you can see this is a standard Spring Boot application so far, but let's go ahead and fix that now. I'm going to add a class, call this AI controller, and I'm going to make this a REST controller. Whew, trying to type too quickly, I think. So I'm going to inject a Azure OpenAI chat client. There we go. We'll just call this cleverly enough client. And you can see that Copilot is trying to help me and says, hey, look, you've got this thing defined, but you're not injecting it. And of course, with Spring Boot, the preferred method of doing that is constructor injection. So it's offering that up to me. I'll happily accept. It's helping me along as I go. Now, it's offering something, and I'm not really sure why it's doing that. In this case, it has no context, so it's just taking a run at it in the dark. And of course, it's not what I want. So let's go ahead and just add, again, a bit more specificity. So I'm going to create a get mapping. And this isn't bad, right? So it's offering this up to me. It's saying, hey, we'll pass a string, we'll get a string. The actual method name is wrong, but I can change that. And this actually would work. It wouldn't do much. It just returns whatever the AI would return from Hello World. So let's get a little bit more into things. But this is a pretty basic good start. So I'm going to define a request parameter. And what I want to do is make this a default value, not of Hello World. I'm going to close that window so we can see a bit more because I've expanded the text. But I'm going to ask, what is the meaning of life? That's not bad. And we will return, and just prompt it or clean that up. We'll take the message, and this is the simplest way of going about a call to the AI. We're passing a string, we're getting a string back. Since we're rather close on time, please take my word for it. This does work, but we want to get into the more interesting use cases as we go. So I'm going to go ahead and go from there and change this to a chat response, because that's where you can start seeing the full response and what's behind a little bit, a peek behind the curtain. So we're getting that message back, but in this case, since it needs to take a prompt, we can pass the same message to it, and it'll return a chat response. And that works. But again, we're going to go a little bit further than that. So I'm just going to go ahead and plow on through there, and we'll go for the gold here all at once. So it's suggesting, or it's assuming, that I want to add another parameter, which is exactly what I want to do. So I'll add request param. I don't want the default value there. I just want to indicate whether it's required or not. And in this case, I want this to be an optional parameter. I do want this to be a string, but I want to provide a celebrity because this actually, we're going to make this a fun response. So what can we do with this? Well, I'm going to take this. I'm going to first create a var here, and we'll call this our prompt messages, because I'm going to expand on this. Rather than just pass a single message, I'm going to pass several messages. So new array list of type message. And yeah, that looks pretty good. Now we need to make sure we have our imports arranged properly, or at least configured properly. And now we have AI chat messages here. At least we have the potential for an array of them. First thing I'm going to do is just do a prompt messages.add. In fact, this is a great point to show you add the user's message. And we see that it creates that. At least, ooh, yeah, that's not quite right here. So let's see. That doesn't seem right. Yeah, it wasn't actually a new prompt, except it's not new prompt. It's actually new user message. I'm kind of getting ahead of myself and in my own head, but we can fix that. So we'll import user message. One thing I do want to point out that with regards to interacting with the AI, there are basically four kinds of messages. One is the user message that you're providing in your prompt, or primarily providing in your prompt. There are others, which I'm going to get to next. You have a system message, which is the way that you describe to the AI how it should respond. So it's kind of system direction, system level direction. Then you have an assistant message, which comes back from your AI assistant. There's a function message as well, but we won't get to that today, but it's there. So really, we want to create a user message and pass that. And of course, we can do that right here. So we'll just do a call prompt messages. And let's see. So new prompt and the prompt messages, because it can take a list of messages as well. So that's fine. However, what about that celebrity? So what I want to do now is just do if celebrity doesn't equal null. That's pretty good. It's trying. I mean, it's doing not a terrible job here, but I'm going to let's take this a bit further, right? So what I want to do here is just create a system message, because I mentioned system message. I feel compelled to use it now. So we're going to just use a new system prompt template, and we will pass in something that says you respond. We're providing guidance to our AI in the voice and the style. Let's do style. That's probably a little more accurate. Of and our celebrity. And then I want to add the create message method, create message, and we'll take a map of celebrity and celebrity. We'll add that. So that looks actually pretty good. Prompt messages add. And of course, we need to import map. And that should help dramatically. That seems happier. So if we have a celebrity that we're requesting a voice of, then we'll use that. We'll add that in. I'm actually going to do one more thing before I run this. Let's just go for broke, because again, time is fairly short. What I want to also do here is create private final list of message, and we'll call this a buffer equals, yep, that works. Again, thank you very much, Copilot. We'll import that, and that looks pretty good. So each time I ask a question, what I want to do is just add, let's see, so we want to add our prompt messages there. But before we do that, we want to add any buffered messages. That works. We'll just add all of those. And then once we get here, we won't just return this. We'll do a var response equals, and then we will add buffer dot add all. Actually, you know what? No, that's just the opposite of what I want to do. So prompt messages, add all, buffer, and then prompt messages add response.get message. Nope, that's not exactly right. Dot get result dot get output. And you see that's an assistant message, right? So actually, I want to move that. Oh, come on. Move this up. There we go. And of course, we'll take that out. We add everything from the buffer. We take our prompt messages, and let's see. And then we buffer dot add response dot get result dot, there we go. And then, oops, need to return response. There we go. Okay. So that looks pretty good. Let's go ahead and run this. I'm going to go out to my my terminal window, and we'll just do a /maven w spring boot run. Boy, this is exciting. It's all in one here. Let's go ahead and open another window. Once we run this, we'll test it, and then we'll wrap up with slides, code repo, and Q&A, assuming this all works. Crossing fingers. What could possibly go wrong in a 10-minute live coding session? We'll find out. So that looks pretty good. It seems pretty happy. So let's go here to 8080, the basic question, which is what is the meaning of life? Of course, there shouldn't be any way that the AI can surmise that. Let me go back here. We see that the full chat response is returned as an AI language model. I don't have personal beliefs. That makes sense, right? So message equals tell us about, let's see, let's go a little more specific. How many planets are in our solar system? And we'll go back here, and we have no celebrity voice, but let's go ahead and add and celebrity equals Snoop Dogg. Why not? Okay, so oops, my bad. I misunderstood your request earlier. Let me try again. So check it out. I can't do a good impression of anybody. I can't even do an impression of myself, so I won't even try. But we have that. That doesn't look bad. So let's go back now and say, because again, we're buffering this. So tell me about the fourth. And if everything worked right, if I remembered everything, and yep, I got confused again. The fourth planet from the sun is Mars. So this is good. We have context. We're repeating. We're stuffing the prompt with all the assistant messages that are coming back, and we're maintaining that context. And the AI is stepping up because, again, we're giving better inputs. We're getting much better outputs. So with that, there's so much more to share. I just don't have the time. So we'll go back here, and we'll wrap up. If you want to know more, I actually have this code and more, and I'm adding more as I go because this is an evolving talk, right? Just like AI. But if you want to go to github.com/mkheck/production-AI, check it out. Again, if you want to reach out to me after the fact, there are my cords. And let's see if there are any questions.